In this tutorial, we are going to discuss the enthalpy diagrams for an endothermic reaction and also an exothermic reaction. Okay, so let's do that by answering this practical question here, which says when a 1 mole of nitroglycerine decomposes, it causes a violent explosion and releases a heat of 5.72 times 10 to the power 3 kilojoules. Okay, then we've been given the chemical formula for this decomposition of nitroglycerine there. Okay, so we have nitroglycerine there, which has decomposed to give us these products here. We have it, and we've been given a balanced chemical equation for that decomposition. Now we are saying, is the reaction exothermic or endothermic? So that's the first question we need to answer. Is this reaction exothermic or endothermic? Okay, once we answer that, we need to draw an enthalpy diagram for it. Okay, so now we are being told that this nitroglyceride is decomposing. Okay, so for most of decomposition reactions, you notice that heat is mostly released. Okay, so there will be heat release there. Okay, so heat is released, and the amount of heat that has been released there will be told it's 5.72 times 10 to the power 3 kilojoules. Okay, so if heat it is released in the system is called an exothermic reaction. So for an exothermic reaction, heat is actually released from the system. Okay, that's what exothermic reaction is. Okay, when heat is gained or absorbed. Okay, so for heat gained or absorbed, we say that type of a reaction is an endothermic reaction. Okay, so we have an endothermic reaction. So in this case, to answer our question there, so since heat is released, this reaction is actually an exothermic reaction. Okay, so now we need to draw the enthalpy diagram for this reaction. Okay, so we need to draw the enthalpy diagram for an exothermic reaction there. Okay, so for an exothermic reaction where heat is being released, the enthalpy diagram will look like this. Okay, so let's have so here we have exothermic reaction. Okay, so I start with the exothermic reaction. Then when I'm done with the enthalpy diagram for exothermic reaction, I also show the enthalpy diagram for an endothermic reaction, just to give you a clear view on how the enthalpy diagram of an endothermic reaction should look. But to answer our question, let's start with the exothermic reaction, how the diagram should look. Okay, so you have the two axes, you have the y-axis. So this is my y-axis. So in this y-axis, I'll put energy. So I can say I have potential energy in the y-axis, and it's showing an increase in potential energy there. Okay, so then in the x-axis here, okay, I'll also say this is the reaction progress. Okay, so this is the reaction progress there on the x-axis. Okay, so now for an exothermic reaction, what you notice that in terms of energy, the reactants will have greater energy compared to the product. So you find that the energy for the reactants will be somewhere there. Okay, so you can have the energy of the reactant. So in this case, our reactant is this one here. Okay, so we can put C3H2 H5NO3 2L there, where I've put R, okay, to show that that's where the reactants are. Okay, then you can have what we call the transition states. Okay, so here we can have this one. So we have the transition state there on top. Then you find that the products for an exothermic reaction, the products are going to be down in terms of energy. You can see here we have increase in potential energy. You can see the reactants, their energy are on top. Then the products, their energy are going to be down there. Okay, so you find the products here, their energy are going to be down. So you put these products down there. Okay, so now this is what we call the transitional state. Okay, then you have the energy difference, okay, between the reactants and the products. So the energy difference between the reactants and the products is what we call enthalpy. So that is what we call change in enthalpy. Okay, so we are saying change in enthalpy is equal to the energy difference between the reactants and the products there. And we are saying that for this reaction, you notice that the reactants will have greater energy compared to the products. So in that case, so the difference, the energy difference between the reactants and the product is what we call the enthalpy change there. Okay, so here you can say the energy difference from here to there. Okay, that is what we call change in enthalpy. Okay, so that's what we have. Then we can have this energy. So you see there's the amount of energy we need to overcome for us to produce our products there. Okay, so here we have this energy that we need to overcome. So from the reactants, where the reactants are starting, to the transitional state there. So this energy is the amount of energy that we need to overcome for us to get our products. Okay, so this energy is called the activation energy. Okay, so activation energy, it's more like you have a mountain, you need to climb the mountain. So the amount of energy you need to climb that mountain is what we call the activation energy. So in this case, the energy that is we need to overcome from the reactants to the transitional state there, it's what we call activation energy. So now, since here we are moving from the reactants going to the product, this activation energy is also known as the forward activation energy. Okay, so we can also get a reverse activation energy when we are moving from the products to the reactants. Okay, so from here, let's say, to the reactants, want to form the reactants. Now we are doing a reversible reaction there. So we also need to overcome this energy here. And this energy is also activation energy now for a reverse reaction. That's what we have there. Okay, so generally the enthalpy diagram for an exothermic reaction will look like that. Okay, so here we have activation energy, the forward one, which we need to overcome for us to produce the reactants of the products there. And we can do a reversible reaction to have the energy that we need to overcome for us to produce the reactant for the product. So this is what we call the reverse activation energy. So that's what we need. That's for the exothermic reaction. This is the enthalpy diagram. That's how it's supposed to look like. Okay. Now, we can also have the enthalpy diagram for an endothermic reaction. So here we've answered our question now here. So this question we've answered. So the drawing is here now. So I also want to show how you have to draw the enthalpy diagram for an endothermic reaction so that we cover all the concepts here. So for an endothermic reaction, if you are asked to come up with the enthalpy diagram for an endothermic reaction, it will look like this. Okay, so you still have your y-axis there where you have increase in potential energy. Okay, then you have the reaction progress here. Okay, so how the enthalpy diagram for endothermic reaction is going to look like, it's actually the opposite of the exothermic reaction. So here you notice that the reactants had greater energy compared to the product. Okay, but in an endothermic reaction, you notice that the reactants will actually have low energy compared to the products. Okay, so you notice that the products here will have low energy. Okay, then okay, so the products will have greater energy. So we are doing the opposite. Okay, so the products are going to have greater energy, the opposite of the endothermic. In endothermic, we had reactant which had greater energy, then the product had low energy. So for the endothermic reaction, you find that the reactants are now going to have low energy, then the products are going to have greater energy. So let me just have a proper drawing there. Okay, so you notice that the enthalpy diagram will actually look like this. Okay, so here you have reactants now having low energy compared to the what? To the product. You can see here in the product, here we are for exothermic reaction, here we are the products which are low energy, but here we are having reactants which are having low energy, and then the products are having greater energy there. Okay, so we still have the difference, the energy difference between the reactants and the products here. And this is what we made mention is called the what? The change in enthalpy. Okay. Then we also have the activation energy, the forward activation energy. So the amount of energy you need to produce the products there. So in this case, we are a transition state, which is here. So the activation energy, the forward activation energy is going to be that one. That's the amount of energy that we need to overcome that's we need to overcome for us to get our products there. So this is the forward activation energy. Then for the reverse activation energy is going to be the amount of energy from there to there. So this is the activation energy, the reverse one. Okay, so that's what we have. Okay, so what you also need to know is that for change in enthalpy, okay, so change in enthalpy can also be given by the difference, okay, so between the activation energy of the forward minus the activation energy of the reverse reaction. Okay, so that's what we have. Okay, and for this one here, we have the reactants which are greater energy compared to the product, but here we're having the products which are having greater energy compared to the reactant. That's what we have there. Okay, so that's what we have. We can also have change in enthalpy for this one, which will be given by the products minus the reactants. So the energy of the products minus the reactants will give us enthalpy change there. So that's what we have. Okay, so now if you want to get more recorded videos on thermochemistry and thermodynamics, you can subscribe with us. Okay, so you can subscribe with us. So how you subscribe? Okay, so let me just show. So this is the toy sheet questions. So if you are at UNILAS, these are some of the questions that we had on endothermic and on thermochemistry and thermodynamics. Okay, so now if you want to subscribe with us and get a whole video on exothermic, thermochemistry and endothermic, thermodynamics. Okay, so you go on the browser like that, then you type Discrete Learning Institute. Okay, so me, I've been typing it, so it's just there. Then you click there. Okay, so it will take you to our website. So if you don't have an account, there will be options where you'll be asked to create an account. Then when you create an account, you should be able to have something like this. You have these pictures here. Okay, so now there are different courses on the website. So you pick the course you want to subscribe for. For example, I subscribe for chemistry. Okay, so once I subscribe for chemistry, I'm able to go where there's chemistry there. I open. Okay, so when I open, there's what the folder there written general chemistry. I can go in that folder written general chemistry. I open there. Okay, so let me just wait for it to load. Okay. Yeah. So let me just wait for it to load. Yeah. So once it opens, you have these folders here. So you have topics, summarized notes, and tutorial sheets, past papers, and lab reports there. Okay. So you can go on lessons there. If you go on lessons, you find folders for different lessons here, from topic 1 to the last topics here, which is topic 25 there. So there are different topics. Okay, so for this one is where you're having thermochemistry. Okay, so see there for the number 17. We can click there by saying thermochemistry. Should be able to find recorded videos, notes, and other supplementary tutorials. Okay, so if you want recorded tutorials, you can just go there. You find the video lessons for this topic, the full video topic on this topic. Okay, so you find it. Also, if you want the tutorial sheet for this for thermochemistry and thermodynamics, okay, so you can go on the folder there written tutorial sheets and assessments. Okay, so you just click on that folder. Okay, then you find different universities, then you pick your university there. Then you can also find these two folders which are having first semester and second semester. So if you're in second semester, you pick second semester, and you should be able to find the video solutions for this topic. Thank you so much for watching this tutorial.